Hello everyone. In this video, we will learn some basics of monitoring and how Prometheus and Grafana help with monitoring. Let's say you have deployed a web application. You need a way to monitor the server's health, like what is the level of traffic we are receiving, how much RAM is being consumed, how much disk space is remaining. Prometheus and Grafana are tools for monitoring your server. In this video, I will explain how to set up Prometheus and Grafana using a single Docker Compose file. Let's start with Prometheus. Prometheus is an open source system monitoring and alerting toolkit. It has a active developer and user community. Prometheus collects and stores metric information with the timestamp at which it was recorded. Prometheus by itself cannot capture metrics. There are other components in Prometheus ecosystem that collects metrics. Once these components collect these metrics, they will expose the metrics via HTTP. It is usually a get or a put API with the path /metrics. Prometheus can scrape the metrics from these HTTP endpoints. Uh, PromQL is a querying language through which we can get the data stored in Prometheus. Prometheus has many components. One is the Prometheus server, which scrapes and stores time series data. There are client libraries. These are plugins that we can use in our application code. There are client libraries for languages like Python, Go, Java, etc. There are special purpose exporters collect data for a specific need. Later in this video, we will use two exporters called Node Exporter and CAdvisor. Node Exporter will collect data regarding the CPU, RAM usage, and hard disk space. CAdvisor will collect metrics regarding running Docker containers. Similarly, we have other exporters that are specific for certain applications like hardware, and we can set up rules in Prometheus that will trigger alerts when a condition is met. These can be conditions like RAM usage reaching 90% or a Docker container stopped. The alert manager handles alerts and takes the necessary actions. There is also a component called the push gateway that can capture metrics for short-lived jobs like cron jobs, for example. This is the architecture of Prometheus. As you can see, the Prometheus server captures data from push gateway and the exporters. This data is used to trigger rules for the alert manager. Using PromQL, Grafana can access the data. Let's learn what Grafana is. Grafana is an open source platform for monitoring and observability that excels in visualizing time series data. It provides a rich set of features for creating, exploring, and sharing dashboards, making it an ideal companion to Prometheus. Grafana has flexible dashboard and we can set up multiple data sources for Grafana. Grafana has a huge community and ecosystem of plugins. Now that we have covered some basics about monitoring, let's learn how to set up Prometheus and Grafana. We will set up monitoring for a simple Node.js application, but this is not specific to Node.js. This will work with any containerized application. This is a high-level picture of what we are trying to build. Every service that you see in this flowchart runs in a separate Docker container. We will use the traffic web server to proxy our request to our Node.js application. Traffic will expose metrics regarding the number of HTTP requests that it receives to Prometheus. Then we have two exporters, the Node Exporter and the CAdvisor that I referred to earlier. The Node Exporter will collect details regarding the machine that it is running on, like the amount of RAM and CPU usage, etc. CAdvisor will collect details regarding the Docker containers that are running. These two exporters will export metrics to Prometheus. And finally, Grafana will query Prometheus and display the metrics in a user-friendly dashboard. Let's dive into the code. You can refer to the code that I'm about to explain in GitHub. I will put a link to the repo in the video description. This is the code for our Node.js application. I have created two APIs using Express. I have written the error or not API to generate data for different status codes. If you pass a text called error to this API, it will generate a 500 error, and if you pass anything else, it will generate a 200 error. And this is the default route. So switching to the Docker file for this Node.js application, it's nothing fancy here. I'm just installing the dependencies and copying the code into the container, and I'm exposing port 3000. Now, so this is the Docker Compose file that has all our services. We have a total of 6 services. They are Traffic, Node.js application, Prometheus, C-Advisor, Node Exporter, and Grafana. All of these services run in the same network called SampleNet. This is a virtual network set up by Docker. We don't need to run all of these services using Docker Compose. It's not mandatory. It is just convenient to have all of these services in one file. There are binary files available for Node Exporter and Prometheus that we can run separately. Node app is the Node.js application that we just saw. As you can see, we are picking up the Docker file here. What we see under labels is the integration for traffic. Let's see how traffic is integrated. This is the configuration file for traffic. In traffic, we can have both static and dynamic configurations. What you see in this file is the static configuration. What you saw in the Docker Compose file under the Node.js application is the dynamic configuration. Under providers, we are telling traffic that we are running it using Docker, and we provide the name of the network in which we are running all our services. The name of the network should be the same name that we present in the Docker Compose file. Expose by default tells traffic to look for dynamic configurations. Endpoints are like port mappings in traffic. We are using port 80 to proxy request for our Node.js application and port 8082 to expose metrics for Prometheus. The metrics section is where we enable metrics for Prometheus. There are a few configurations on what we can include in the metrics, like putting the request into different buckets based on the response time. We can enable metrics on the route level as well. In our case, we have the /error or not API route. Entry points is where we can specify the ports at which we will expose the metrics to Prometheus. Switching to the dynamic configurations, first we have enabled traffic for the Node.js application. Then we have specified the entry point. In this case, it's web, which is pointing to port 80. And we are telling traffic to redirect any request that comes port 80 into port 3000. This is the port that the Node.js application is running inside the Docker container here. So, and the path prefix tells that just redirect any request that is coming, any path. Under volumes, we are copying the code into the container, and we have specified what command to use to run the Node.js application. In the traffic service, we are passing the configuration file and giving access to watch for Docker events. This is how traffic will read the dynamic configurations, and we have exposed ports 80 and 8082 outside this container. So far we have seen how the application functions. Let's see how we have configured Prometheus. Remember that Prometheus works by scraping data from various HTTP endpoints. This scraping happens once every 15 seconds. We can set the scraping interval in the global configuration. Here we can set the scraping timeout. in case a service crashes, Prometheus shouldn't be waiting for the API call to end for a long time. We won't be covering the alerting manager in this video, but the configuration will look something like this. Under the scrape configuration, we can set up multiple jobs that will run and scrape the necessary data. The Prometheus job will scrape data about Prometheus. We can configure the scrape interval and the scrape timeout at the service level also. This will override the global configurations. We can also modify the path that Prometheus will use to scrape the data. The target section is where the domain or the IP address where Prometheus is running. Since we are running everything using Docker Compose, Docker has a built-in feature that will map the service name in the Docker Compose file with the IP address of the container. So Prometheus here refers to the Prometheus service that we have in the Docker Compose file here. So this name will be mapped with the IP address of the container here. So Docker will do this for us. Then we have the node job that scrapes data from the node exporter. Every job we mention here will run independently and it will store data in a common pool. For a single job, we can have multiple targets. So we can pass an array here. Again, the node exporter that we see here will be mapped to the node exporter service that we have in the Docker Compose file. The configuration for cAdvisor and traffic are the same. If you compare this configuration with the flowchart, you can get a better understanding. So now these are the jobs that are running here. So we have the traffic job that scrapes data from traffic. We have the node job that scrapes data from the node exporter, and the same for cAdvisor. Let's see how the Prometheus server is configured in the Docker Compose file. We are using the official Prometheus image and we are exposing port 9090. We are passing the configuration file that we just saw through the volume mapping here. We are storing the data using this named volume called prom data. The cAdvisor service is configured in a similar way. We are exposing port 8080. Notice that this is the same port that we configured cAdvisor in the cAdvisor job here. To collect metrics, cAdvisor needs access to the volumes of the host machine that is running Docker. So that's what we have did here. This is why we are mapping these volumes of the host machine with the volumes inside the container. $R that you see here means we are mapping in read-only mode. The node exporter service is configured similarly. Along with the volumes, we also need to run a few commands to set the path that it needs. For Grafana, we pass a few environment variables to set the user name and password that we can use to log into the Grafana dashboard. Under volumes, we are passing the configuration file for the data sources for Grafana. As you can see, we have set up Prometheus as the default data source along with the URL to access the Prometheus service. Now let's run the Docker Compose file. Go to this directory in your terminal and first we need to build the Docker file. So the Docker file that I'm referring to is the Docker file we set up for the Node.js application. So this command docker compose build will detect the Docker files that we have in the compose file and it will build them. So since I already ran the build recently, it won't take me a long time. For you, it might take a few seconds. Now to run the services, let's do docker compose up. So all the services are getting initialized and they are loading now. So to test whether all the services are working fine or not, let's start with traffic. So we are running traffic in port 80. So if we go and access localhost, this means that traffic is working properly. So traffic is sending the request from, I mean, it is processing the request to the Node.js application. So this hello world is coming from the API, the default API that we have configured here. So let's access this error or not endpoint to generate data for traffic. So let's generate a few 500 errors. So now we have generated a 500 error according to the code, and let's generate a few more 500 errors, and finally let's generate a 404. Yeah, so that should give us enough data in traffic. Now let's see whether we can get metrics for traffic. Remember that all the services expose data through the slash metrics endpoint. So if we access localhost 8082 slash metrics, we should be able to see the metrics that traffic is exposing for Prometheus. 8082 slash metrics. So yes, these are the metrics that traffic is exposing for Prometheus. Now let's check whether Prometheus is running or not. So Prometheus is running in localhost port 9090. So this is the Prometheus expression browser. You can run PromQL queries here to check the data present in Prometheus. Let's run a sample query to get the average network traffic received per second. To do that, we can, I already have a query here that we can run for the same use case. So let me paste that here, and if we execute, so we can see that, see the data that it has scraped, and we can check the graph as well. Let's check whether cAdvisor is running. So cAdvisor is running in port number 8080. So cAdvisor also has a dashboard. It can show the details of all the containers that are running in the current system. So if you see, this is the cAdvisor container itself. This is Prometheus. This is traffic. This is Grafana, and Node exporter, and the Node.js app. You can ignore this. Now that we have all this data, let's switch to Grafana and build dashboards to visualize this data. Grafana is running in port number 3000. So we can use the same credentials that we used in the Docker Compose file here. So the username is admin and the password is Grafana. So we can log in. Once we log in, let's check the data source under the data sources section. So you can see that Prometheus is already configured as the default data source as per our configuration. Now let's create a dashboard for Node Exporter. So to set up the dashboard, let's go to the dashboard section and let's create a dashboard. So there are many open source dashboards available in Grafana. Let's set up one of them. So click on import dashboard. Now we need an ID for the dashboard. Most open source dashboards have an ID. So this is a dashboard for Node Exporter that's available in Grafana. So this is a preview of the dashboard. Then you can copy the ID of the dashboard. You can come back to Grafana and you can paste that ID here. So this will load data regarding the dashboard. Here we can set Prometheus as the data source. So once we click on import, that's the dashboard for Node Exporter. So you can see the CPU usage, the memory usage, the RAM usage that are running. You can also check the network traffic here. So yeah, So if you remember, we specified multiple targets in the Prometheus configuration for traffic. So since we only gave one endpoint to scrape the data from, so that's the endpoint that we see here. If we add multiple targets in the target section, we would have more items here that we can switch between. Let's create another dashboard for traffic. Similarly, let's go to Grafana, and this is the official dashboard for traffic. We can copy the ID of the traffic dashboard. Here we have to create a new dashboard, import the dashboard, give the ID of the dashboard here. Select Prometheus as the data source and click on import. So, yep, this is the dashboard for traffic, and it has data for all of these different endpoints that we created. So you can see the 404s and the 500s that we generated. Right now, since we didn't generate a lot of data, I just wanted to show you how the error codes will look like, how the different requests and different error codes will look like. Let's generate one more dashboard for CAdvisor. So same drill, we copy the ID. You can go to the dashboard section, put the ID there, load the dashboard, and select Prometheus as the data source and click on import. So just as we saw in the CAdvisor dashboard, how we have the different containers that are running, we see the similar data here, but the data is very rich. We get more details here, the amount of CPU usage all in one single dashboard, where here it shows the CPU usage as per down to the container level. So this will be pretty useful when you run your application in different containers, and if you want to analyze how much memory is being used by the different services that you're running. We have reached the end of this video. I hope you learned something useful that you can apply to your own projects. I will leave a link to the GitHub repo in the video description. You can check the entire source code there. Also, I have a Medium blog where I explain all of this. Do check that out as well. Thanks for watching the video, and have an excellent rest of your day.